Welcome to this practical session of the Copernicus Marine Physical Reanalysis Asia training. Today we will explore one specific global product developed and distributed freely through the Copernicus Marine Environment Monitoring Service. The product is the Global Reanalysis Ensemble product that consists of 4 different reanalyses with the same temporal and spatial resolution. The objective of this exercise is to visualize maps, vertical section of temperature, salinity, mixed layer depth, density in one specific subdomain. We'll plot the ensemble mean and the standard deviation. This product includes 4 different ocean analyses with a spatial resolution of 1/4 of a degree and daily and monthly frequency. An ocean analysis is an homogeneous reconstruction of the 3-dimensional physical state of the ocean over the last decades. Such reanalyses are constrained by observation and in agreement with the model physics. The peculiarity of this product is the multimodal approach. You can in fact estimate both the ensemble mean and the standard deviation. The standard deviation is a measure of the uncertainties of the ocean state. More information about the dataset can be found in the dedicated product page on the Copernicus Marine web portal. Those are the parameters used to download the data. The mean and the standard deviation for temperature, salinity, and mixed layer depth are downloaded. We select an area of the Western Pacific for 2 different seasons. Specifically, we select January and August 2018. In the same product, together with the ensemble mean and the standard deviation, you can also find the 4 different members in the case you would like to see the specific behavior of each reanalysis. The data are already in the local environment, but in the case you need to download it from scratch, you can directly download it from the web portal, from the dedicated page of the CMCC catalog, or using this client called the Motu client, that is a multi-platform Python script to automate extraction of information and data from the Marine Copernicus portal. You need first to install the client and then proceed with the following instruction to download the data needed in this training. To plot the data, the following library and Python version are required and should be installed in the environment. To check the version of the Python in your environment, use this instruction here, and for the installation, use this other instruction. Those are the other modules used for plotting data and calculate the density. Similar procedure if you want to install these modules here. Once you have installed the module, you can import them inside the notebook. To go cell by cell, just click the button, the run button here, and start importing the module. and set the paths to the data. Now you can access the files that you have just downloaded by using commands from the Xarray module. Those files are in a netcdf format, and let's take, for example, the winter file. And with the command info you can see what's the attribute that are inside. So you have a general attribute of the data set, and then you have the variables selected together with the coordinates. If you want more info about the coordinates, use the command coords, and to select the values of each coordinates, just put the name in this way, and you will see all the values, all the levels in this case for the depth. To have information about the variables that are in the files, use these instructions. So the name is composed by two parts. The first part is the physical name. So you have temperature, salinity, mixed layer depth. The second part instead tells whether it's the ensemble mean or the standard deviation. For more info on the specific variables, you just need to put the name inside the brackets. Those are examples. You see, for example, that the standard deviation of temperature is function of latitude, longitude, and depth. And so is a three-dimensional variables, while if we want to have attributes for the mixed layer depth, you will see that the mixed layer instead is function only of latitude, longitude. Let's start to set the configuration for plotting the variables. So let's define the name of the coordinates and the name of the variables. We can choose for this example the summer. And we choose to plot temperature, ensemble mean, and standard deviation. You can change the variables to be plotted by this way by uncommenting these lines here. We are now selecting the area. Again, you can customize the area by uncommenting these lines and putting the latitude and longitude you would like to see. Here you can set the desired depth. We have now generated the plots. So the first plot on the left is the temperature in August 2018 at 100 meters, while on the right you have the corresponding error for the same period and depth. So you can try to answer the question arised, and also to have fun by changing the variable inside the plot, changing the area and the depth level, etc. The second part of the exercise is the transect. So let's start plotting the transect. Here we set the coordinate minimum and maximum values, and also the depth minimum and maximum. Here instead we define the name of the variables, so you have temperature ensemble mean, salinity ensemble mean, mixed layer ensemble mean, and the corresponding standard deviation. If you want to check the vertical level we are going to use this instruction here. And we can now plot the temperature and ensemble mean and standard deviation. You see on the left the temperature as function of depth and latitude, while on the right again the error that correspond to this transect. So you see the classical decrease of the temperature from the equatorial region towards northern latitude, and an increase of the error where the temperature gradient is very high. Those plots were for winter time. Now let's plot the same for summertime. And we can do the same for salinity. And salinity in summertime. The last part of the exercise is how we can plot the density from temperature and salinity. And so this is basically also a way to propagate the error from temperature error and salinity error. You can also calculate the density error in this way. The left plot shows the density in the same transect. On the right you have instead the error associated to the density in the same transect. The black line corresponds to the mixed layer depth, while the dotted line shows the error associated with the mixed layer. This is for winter, and now let's plot it for summer. So here you have seen the impact of the season on the physical property of the marine water. Now you know how to plot ensemble mean and of physical variable and the corresponding standard deviation. Thanks.